Multiple choice. Here we go. So this looks definitely like a U substitution because I see something to the fourth power. So let's make that U the 2 minus 3x. So that du is -3 dx. All right, so I don't see a -3 there for the dx, so I will make that -1/3 du equals dx. So when we take the antiderivative, we're going to have a -1/3 out in front, and we're going to have u to the fourth power du. All right, so the antiderivative to this guy is 1/5 u to the fifth plus c, okay? And we want to make sure that we got -1/3 out in front. That gives us -1/15 u, which is 2 minus 3x to the fifth power plus c. All right, and it looks like this is the guy right there, so the answer is D. Okay, that is always refreshing when you see your options there. All right, next one. Now this would feel like an arctangent, but that x is messing things up. If it was a 1, not arctangent even, because it's a square root. It might be like a cosine. I can't remember. I wish I had my tables in front of me, but I don't. So u is going to be this 1 plus 4x squared, and then the du is going to be 8x dx. All right. Now with that, we have 1/8 du equals x dx, and that is right there. So we will put the 1/8 in front of our integral here, so that we have 1 over the square root of u, which is u to the -1/2 du. Okay, now even though it's -1/2, it makes it just simpler. What do we got? We're going to add a degree, so we're back to positive, okay? But because we need a 1/8, what we want to do is that 1/8 is there, so we're going to multiply. There's not one here though, so we will multiply by 2. Okay, so then that way the 1/2 comes down, multiplies to the 2, we get the 1 there, and the 1/8 is still right there. So this equals then 2 times 1/8 is 1/4, the square root of u, which is 1 plus 4x squared plus c, and that guy is right, not there. He is right there. Okay, nice. Okay, now this guy looks like, well, we're going to have to do a u. U equals 3x plus 1. Let's take that 2 out of there, by the way. We can do this actually in one move. We don't even need a u situation for that. Okay, so we can literally ignore the 2 until the very end, okay? So now the u equals 3, and that would be du dx. Now we don't have a 3 dx. We put the 2 over there because I don't feel like dealing with it, but we are going to have to do a 1/3 du equals dx. Okay? So now what we've got is we've got 2/3 on the outside of there, and we are just going to have u to the -1. Okay, so the 1/3 came out. Okay, this 2 was completely ignored. We took them out at the very beginning, but when we came out with that 1/3, we also still have the 2. So together, those guys were separated out so that we have this nice clean antiderivative. And you can kind of see where this is going now. You can see that the antiderivative of this is ln, and then we've got our u right there. And then don't forget the 2/3 in front, and that looks like A. All right, beautiful. Okay, now this guy looks a little crazy. I actually don't like the way he looks. I'm going to go ahead and do this. I'm going to split him up. Now look at how easy that was. That's pretty cool. What I can also do is I can keep splitting him up. I will split him up again. So now I got the antiderivative of 1 dx plus the antiderivative of 1 over 3x dx. Okay. Now I know this guy is x plus c. Okay. And then I'm going to add my two c's together, and guess what I get? I get c because but anyways, I'm jumping ahead here. Let's get rid of that 1/3. Okay, and now we have the antiderivative of 1 over x dx, which is just the ln. So, what does it all equal? It equals x plus 1/3 the ln of x plus c. So, just so that you know, if I get a plus c for here and a plus c for here, since I don't know what either of the two c's are together, they're just c. You could put a 2c there, but that 2c would just be a c. So it's kind of weird, but it's just that unknown piece. Okay, so it looks like that's a. C is just indeterminate. We don't know what that constant is. Is that right? Yeah, okay. All right, last one. This looks like an arc sine. So what we got to do is we got to follow the formula, but unfortunately I don't have it in front of me. Okay, I think I shouldn't say that, but I believe it's 1 over a. Okay, or is it? Well, no, it's u over a, right? And then it's arc sine, and then it's u over a, right? Yeah, so this, and I think this actually is du, or anyways, the thing is that because u is actually just u, our a is going to be 3. This is a squared, so that means the a has to be 3. So to take the antiderivative is just following that formula. So in the beginning of Calc 1, or at the end of Calc 1, early Calc 2, you're just kind of following these tables there and looking at the formula, making sure you can adapt from one to the next. So this has got to be it. All right, and that covers the antiderivative. No, we still got more. Where are we at? 7 minutes. I'll go a few more. We're going to cross some of these out too. Okay, well, I don't like that. That 2 is in the wrong spot, so I'm going to go x cosine, and this is going to be cosine of 4x squared. Okay, dx. All right, now I can clearly, now the 2 is, that 2, if it was there, then my u would have been something different. And that would have taken us to another level of issues. But here I can actually use my u as 4x squared. So let's see where it takes us. Du is 8x dx. And it looks like we do have an x. So let's go ahead and divide by the 8. So 8 du equals x dx. Now here is our x dx. Okay. Or here, I rewrote it, so maybe this would be better to loop that. So there, with an x dx, I've got 1/8 in front. So 1/8 antiderivative of cosine u du. Okay. All right, antiderivative of this guy is actually one of the easier ones. You don't have to worry about negatives because the antiderivative of cosine is just sine. Oh, nope, no more du, and it's plus c. So the u is sine 1/8 sine 4x squared dx. No more dx either, plus c. So which one is that? 1/8? 1/8 right there. That's the guy. So it's D. All right, beautiful, beautiful. Okay, so Remember, one of the rules of thumb that you probably want to do is always gun for the u being the denominator. Okay, so let's see if this takes us anywhere. We're going to make u equal this guy. Let's see, du equals just e to the x dx. That's perfect because that's exactly what I got. Perfect. Okay, so it equals the denominator, take the derivative, and this guy goes to 0, so perfect. So what I've got is I've got a antiderivative of just u to the negative 1. I have no fractions, so this is pretty clean. And that actually is ln. The ln of u plus c. So let's go ahead and plug that u back in there. And what do we get? We get the ln. Now notice each step I'm making an equal sign, by the way. I noticed that on your quizzes you guys weren't putting a lot of them down, so make sure you do put those equal signs. So we're putting the u, put that guy back in. Looks like that's the guy right here. C is the correct answer. All right, keep on going. We'll just finish out the derivatives or the indefinite integrals here, and then 35. No, we might as well just do 35. 36, we canceled. We did not, unfortunately, get to that. That is pretty trippy, but we're not going to do that this year. We just won't have time. U in the denominator, but I do see a 1 plus sine theta. That makes sense, that this would be just a negative square root. And by negative, I mean like a negative 1/2 square root. So let's make this a u 1 plus sine theta, so that du is actually just cosine theta. The derivative of 1 is 0, and the derivative of sine is cosine. So that's good. That is exactly what I have right here. So it looks like I have the antiderivative, or the integral of u to the negative 1/2 du. Okay, so moving forward with that, I'm going to add a degree, and that would give me 1/2 plus c, but I also have to have a 2 in front there. And so now 2 times the square root of u, which was 1 plus sine theta, plus c. And that is exactly what this guy is right there. Okay, so 35. If f of x is continuous on the interval going from a to b, and c is somewhere in the middle, okay, then this guy, c to b, has to equal some of these formations. Okay, this is kind of crazy here, okay, but you can only choose one of them. So what I'm going to do is I'm going to set this up so that we can say that if we go from a to b of f of x dx. No, my bad. If we go from a to c f of x dx plus c to b f of x dx, that has to equal, I needed more space. Okay, I'm going to abbreviate this. Okay, I'm going to go from a to c plus c to b equals a to b. Is that okay? All right, so I'm just going to trim the fat there. And what we can do then is, if we're looking for this guy, okay, we're going to subtract this guy over to this side, and we're going to see if it actually is one of our choices. Okay, so I just move this guy over to this side, treating these like just like a linear equation. Okay, a one-step equation. So let's see if do we have a b over a minus a c over, yes, that's the guy right there. Okay, so we just moved this guy over to the other side, and that's exactly what he is. So it's got to be a. All right, that wasn't too bad. It looks crazy as heck, but that's all that this is saying, is that c is somewhere squeezed in between here, so we can connect the dots. We can connect these two integrals by having c here and c here. Okay, All right, so another big one.